Back in the day when you look at stuff, how it was made, like even toys back in the day, everything was made of metal.
Mm-hmm.
It was steel, right? Like you look at, like now it's like we watch Pickers, right? And they're always like trying to find those old toys from the 20s, 1920s, 1930s, and wind up, even earlier, they were all made of steel. Well, back then, if you think about it, I mean, this is before most people's time watching this show.
Okay.
Plastics didn't even exist. Like, think about that.
That's why things were made out of plastic.
Think about that. There was no plastic. I mean, I don't know when they started. I don't know when they invented the thing. Was
Well,
it the
a long
30s?
time ago,
But at some point, until it started actually producing, I mean, think of like all the old car parts, the dashboards, they were all metal, solid metal. The steering wheel is some weird, I don't even know what they make steering wheel though. Were they metal back in the day? The model, were they wood?
Well, both.
Wood covered metal sometimes.
Yeah.
Metal,
So
steel.
there's just no plastic. It didn't
Hydroform
exist.
tubes, maybe. I'm not sure.
Yeah.
Well, technically, I did just recently see that they do make a specific like metal series of toys now, like with little dump trucks and stuff,
Yeah.
like this big.
Well, to me, if you're going to get
So
a
you can
kid
get
a
'em
dump
still.
truck,
Yeah.
it should be metal.
Yeah. Well,
I
they
mean,
weren't for a long time.
Tonka should be metal.
Yeah,
Okay,
they
you could
do
have-
make them.
You could have plastic components to it, but the main
So here's the issue with
needs
that.
to be metal.
Plastic
Yeah.
gets a bit of a bad reputation, and somewhat rightfully so, but also somewhat wrongfully. The reason behind that is the plastics you see in consumer products. They use plastic because it's inexpensive to mass manufacture, and as a result, they're using cheap plastics, and they're not using a lot of them. And oftentimes, they're not designed to last forever because, well, it doesn't need to, usually. Usually, it only needs to last as long as
It's
it
a
makes
disposable world nowadays.
sense. Right. The reality is people care more about the initial price than the durability and the life. So what does that mean? Right. Sometimes you see plastics on headphones. And is
Well,
that
a lot
always
of times you see plastic.
is that always bad?
In fact, the lower cost you go, the more
plastics
it's
you
almost,
tend to see.
You almost see no metal. The only metal you might
Right.
see is the stamped out speaker driver inside has some metal
Right.
on it, right? To hold the magnet.
One of the gripes I have here is people often look at plastic like it's an evil, and that's not entirely true. Plastic can be phenomenal, and in fact, there's a lot of applications where plastic is the superior choice, and a metal will be a very poor choice.
Yeah, the key with that, from an engineering standpoint or design standpoint, is knowing where to implement it.
Yeah.
Particularly if reliability and durability are
and
part of the game.
It doesn't rust.
Oh, yeah,
you
that's
don't need to
true.
paint it in a lot of
Right.
applications.
Yeah, whatever color it is,
The same color is typically
it's
through the
through.
material, so you could scratch it and it's the same color through.
Yeah,
It's
right.
non-magnetic.
Yeah, you
know.
can see where
There's a lot of advantages.
It's got pluses for sure, but
Right.
you gotta know where to put it. And then of course, you should probably also talk about the fact that all plastics ain't the same.
No.
There's a lot of choice in plastic in the materials.
A lot of people think plastic's plastic, all plastics breaks. Well, plastic breaks if it's plastic, kind of like all glass is brittle and breaks or something. I don't know, whatever Jerry or everything says. And that is not true at all. There's almost unlimited combinations and variants of plastics, and they all serve different purposes. And the price of these are quite wildly different. So what that tends to mean is in consumer products, the plastics you see are very uniform. They're the low-cost plastics that are economical to produce, that don't wear the mold out, so you get long life, and as a result, cheap unit cost. However, there are plastics that are a superior choice in a lot of applications, especially when you're worried about things like corrosion resistance, impact resistance, and stuff like that. It very depends on the application, but there's a lot of applications where plastic is superior.
Solid plastic toilet seats are
Like
pretty,
they don't really break
pretty
that
reliable.
often, right?
Yeah,
Well,
you wouldn't want a metal toilet
Yeah.
seat,
Yeah, I remember back in the day, I used to have wood toilet seats
Well,
with
yeah.
brass hardware, and all those things didn't look good after a year or so.
Yeah, they rust, you get streaks
The
and stuff
brass
like
would all
that.
corrode and stuff.
Right.
Yeah, there was no good way to keep that.
Well, I know in like the higher end, they have tool grade plastics for like drills and stuff. What that means is they put glass in them, essentially.
Right. Like a well-designed tool usually uses a bit higher grade plastic that oftentimes has some sort of glass or carbon or something reinforcing it. And usually they're much more durable. And you don't really see them cracking except in the cases of bad design, negligence, extreme abuse, and things like that. And of course, you could design plastic to never fail. That's not the question. It's just it costs more, it uses more material. And if it doesn't matter, usually nobody's going to design it that way. But there's a lot of applications. We have some cables over here. I think this is one that, oddly enough, people were talking about recently on HeadFi.
Well, they were talking about difference between like a molded connector, which is what we do on our Diana, which is shaped. Oh, yeah, it's over there.
Yeah,
I'm looking at the wrong screen.
That's right.
Yeah, but the Diana, and then I don't know what this is, just an aftermarket cable, which I don't even know if that's a 2.5 millimeter plug. It looks like 3.5. But the point is, that's the type of plug the aftermarket guys would use on a Dana because they don't have the mold to make it, right? So they're going to use a connector and they're going to solder the wire to it and they're going to put heat shrink on it like that as a strain relief. And, the differences between the two connecting into a headphone like this.
When you look at something like this, people would say, well, that's metal, so metal's better. The issue is you need to be concerned about what about the metal makes it better. You need to be concerned about why you prefer that method. Because a lot of people look at that and say, well, the metal's not going to break. And that might be true, but depending on the plastic, that's not going to break either. So if you look at the intended use case on a cable like this, if you put stress or strain on the cable, this has covered in a jacket. And most likely there's a conductor underneath there that's covered in this jacket. So if you yank on the cable, the stress is going to go through this jacket and to some extent into the cable itself and then into the connector. And then how does this force transfer into this assembly? That's a significant issue. That's the failure point.
When you're actually doing a soldered connector, which both of these are soldered connectors, but when you're doing what they call, that's a removable connector where you can actually take it apart, put it back together, right?
Yeah.
There's some sort of strain relief in there that's made to usually it's just folded metal. You fold metal on the wire inside. Well, the wire can still pull out of that folded metal. So now you need a way to somehow adhere the wire itself to the metal. And what typically holds the most strain is the solder joint. When you wind up over time, when you wind up pulling on a soldered connector like that, because the wires when you look at this, the strain relief is basically holding the jacket, the shrink is holding the jacket to the connector. But we don't know what the wire inside is being strained relief
The
by.
wire may not be held.
So you pull on this, then sooner or later the wire starts getting yanked on, then the conductor gets yanked on at the solder joint, and over time you could have failure. And I'm not saying this cable will fail. I don't even know who makes this cable, all right? But bottom line is that I'm saying that without seeing what it looks like, you don't know really how well it's going to hold up because you can't see the interior.
Right.
But that's normally a problem unless you fill that with epoxy or something.
Yeah, you could pot it.
Yeah,
but then
which is
essentially
really
you're ending
difficult.
up with a plastic connector that's just covered in metal.
Yeah.
Right.
So it takes, when you make hand soldered connections like that with off-the-shelf connectors, it takes more care and experience for that thing not to fail over time, where a molded like this,
well, it's solid.
Yeah, the solder joint, the wire, everything's inside that plastic, right? And then the plastic's forced into all the nooks and crannies and becomes one piece.
We got some B-roll of these being made. Presumably you're watching this now.
Yeah.
So we start out with the raw conductor, right? You solder on the end. We have a little crimp ring and a strain relief. All this stuff gets assembled. What we try to do is connect everything together so that if you put force anywhere on that conductor, all the things act as a strain relief to some degree in unison to give it added strength.
Yeah, there's not any one component that's taking all the abuse.
Right.
The whole thing's a system that's strain relieved internally. And of course you can't see it on this either.
No, you can't see it. It's inside that shell.
But it is basically forced under pressure to fill all the voids, and it definitely grabs on the wire, the conductor. It seals in the solder joints. It's grabbing the strain relief tube we have there and the outer jacket. Everything's adhered to in one shot.
Right. Everything is completely encapsulated and bonded together mechanically in a way that's very difficult to fail or fatigue over time. So if you put strain or stress anywhere on there, it transfers very efficiently, very effectively, very reliably into the shell or something that's designed to handle it. And that isn't always the case, and in fact, usually is not the case with a design like that. It's not to say it's not possible, but it is much more difficult with a design like that to do it properly, and as a result, it usually isn't done.
Yeah, or it's not. Yeah, it's done to a point, and then that becomes a failure point, and that's how companies that make handmade cables like that learn over time is. You got to fix your own cable, and you start to figure out what's causing it to break. And then you hopefully you figure out a way to solve that so it doesn't do it in the future. And it takes a while. We've been doing cables for 30 years, but it takes a while until you get this stuff out in the field. You may not realize, you put that shrink in and go, it'll hold like crazy, and then you find out that the solder joint keeps breaking off on the negative lead in the connector, and you don't know why because,
Well, it's also increasingly more important on a small connector like the 2.5 millimeter. You have so little area. You want to use as much of that area to actually hold the
It's
the
an
cable.
extremely difficult connector to strain relief too, because there's so little material there
Right.
to grab the wire. But anyway, aside from that, we also should probably talk about, because the reason we use plastic is because we can make a specific shape, like that. It's a what do you call
Like
it?
a D, yeah.
shape. Right? It's made to fit in the Diana headphone one way and one way only, and make a flush look. Right.
Right.
And so, but that's not even was the appearance part of the problem, but the part of it was that we didn't want the jack in the headphone to take on undue strain.
Mm-hmm.
So the body of the connector, because it fits almost perfectly into the notch in the headphone, the body is actually what's moving around, right? And the body is making intimate contact with the shell of the headphone, where most of the time the pin is what's is being moved. The pin, the center pin in the jack, is having its way with the jack, right? Which sooner or later you're going to break the jack.
Right.
So the idea was to not have the pin move.
The priority behind this design, and this is just one particular use case for plastics,
Right.
but I guess that's what we're focusing on for now. The priority behind this design was durability, reliability, and to ensure that in the event of a very unusual excessive force, like the headphone gets thrown to the ground with the connector in it, what is more likely to fail is the cable rather than the headphone, because it's easier to fix the connector than the headphone. Like, I think that's a rational approach, right? All these things, of course, are
Yeah,
considered.
the cable you can repair or replace.
Right.
You can the headphone too,
Yeah,
but
right.
it's a little more difficult.
So that is actually extremely durable, but it's not necessarily just because of the connector, it's how it's implemented. And this is often the overlooked feature. The 2.5 millimeter can be a very weak connector. It could also be a very durable connector. Very much depends on how
Well, if
it's
you don't
used.
use the pin as a strain relief,
Yeah, well, that's
Yeah.
the thing.
life is good.
You're not actually using the
want
actual
the-
2.5 millimeter to save it. It's
Yeah.
the whole body.
Right.
That,
That's the idea. Is the
Yeah.
body is the one taking the impact.
The force
and
gets
it's-
transferred
The force
into
is
the
transferring
shell.
into the shell, right?
rather
not
than the
not the
connector.
pin. And that's where you've seen in the past years, people have had headphones that have connectors like this on it, and they go, "Oh, I broke it right away, or I did this, or I dropped it and it broke." So they might assume that all headphones that have these connectors like that. And it depends on the overall design.
Right. That is not always the case. Sometimes you'll see people with external connectors that are small, and that's a very risky move to use a small connector externally like that if it just sticks out of the headphone. Because then every time you put any strain or stress, if you hit it into something, not only you're more likely to hit it into something because it sticks out further, but all the stress goes into the connector body. And on top of that, most headphone assemblies don't have strain relief on the connector. They're mounted to a PCB or a small assembly that's held down by maybe a couple screws or plastic heat stakes or something. So all the force goes into the connector, which can't really take it that well, which then goes into this PCB assembly through solder connections, which really aren't made for that.
The solder joints are usually let go first.
Right. And then
The
maybe it's
jacks are
held in
pretty
by a couple
durable.
screws or something like that on standoffs, but there's a lot of flex in this assembly, and the strain doesn't get transferred very efficiently, and usually something breaks.
But we knew when we designed Diana, we knew all this coming in because, in part, we've all been in electronics a long time, and we've seen we know how
failures.
things fail.
Yeah.
I've been doing it my whole life. So, but yeah, bottom line is we basically do, that's the idea of, and the reason that's the reason it's not metal is because there's no good way to make a metal shell. We could have used a round connector like that.
Yeah.
And made an opening in there that was just fit in. So that body itself, but then it would only be useful for that.
That's part of the
one
issue.
round connector. And so, and we knew people wanted to use aftermarket cables.
Of course.
So we purposely made the hole as small as we could, all right, and yet knew that there were connectors available that would fit in it.
yeah, we did try it.
But we didn't want to make it too big because now that opens up the floodgates for any connector is going to wiggle in there and possibly break
You want to minimize the
jack.
wiggle
Yeah.
while
so
still
we
retaining
purposely made it as
compatibility.
small as we could, yet knowing that there are solderable plugs like this available that don't
Yeah.
have, with the body, that would fit. And people have aftermarket cable guys have figured it out.
Yeah,
what
it has
fits and what
aftermarket support.
Yeah.
I think that's important.
But that was important to us is still, even if you bought an aftermarket, we figure, well, if you can find a connector that fits in there, it's going to fit snug.
Yeah.
And that's great because that's the body is what you want it to hold. You don't want the pin to wiggle around inside there because it's going to break something sooner or later, guaranteed.
essentially
We've been really fortunate. I think we've seen one jack break in all the headphones we've ever seen.
one jack.
Yeah, and it was aftermarket. It was an aftermarket cable he was using, you know.
Yeah.
And
Well, it dropped on the ground.
right, yeah,
That's the worst case scenario.
right, yeah,
Yeah,
But I
hit
mean-
landed right on the jack, popped the solder. off.
yeah. But the stock cables are great. I mean, just super reliable. So no complaints there.
Yeah, it's a well-considered design, and obviously it still could break. Like if you're using it as a tow rope, it's going to break. But it's honestly very durable. And failures are very
anything
rare.
can wear.
Of course.
You know, like we talked about that with like the Apple charge cables. It's like, you know, they try their hardest to make
Yeah.
a small cable flexible and, you know, durable, but you
They're-
bend
it's
any
notorious.
cable enough
Yeah.
times back and forth,
It'll break, yeah.
it's going to break.
And it's always a trade-off. You can make it thicker, but that doesn't necessarily make it stronger.
Yeah, something
Everything's
else
a
will break.
trade-off. Something's going to break.
Yeah.
So you got to consider the whole system, and the system was designed to function fairly well together, and it does. And of course, it still has aftermarket support, which we agree is important.
But yeah, bottom line is that's you could see the need for plastics in certain parts where they're very durable and they fit the application,
Well, for
know.
this, plastic is better than metal.
right?
I think it's very hard to dispute that. This plastic performs more than one function, whereas that metal performs almost no function. It looks like it's strong, but the force doesn't transfer into that shell effectively, and that shell isn't really going to support the thing very well, because now you have the force that you're worried about coming out of this cable, and it needs to go into the connector. That shell doesn't effectively transfer it because it's only retained by this heat shrink. So now you have the solder joints and all the inner geometry inside there that's transferring the force, but it looks like it's strong. It just really isn't necessarily. If you had it potted
without seeing the
inside, that would
inside,
make
yeah,
sense.
It could be potted.
It could be durable
It
as
could
hell.
be.
Yeah.
It could be.
They
But
could have
it's
gooped
typically
it.
difficult.
Yeah.
And curiously enough, what you see oftentimes on a lot of high-end cables for things like iPhone and things like Apple is pretty good actually at making cables. Now they tend to prioritize aesthetics and small diameter, but they oftentimes have 1, 2, or 3 molds inside the thing. So they'll do a plastic over mold, hold everything together, and then do a one over that's a different durometer, so it's stiffer and it transfers forces in a reliable manner. And then they'll put one over that for the aesthetic. So it looks like plastic or rubber or something, but inside there's all kinds of stuff that may be going on, but it's an engineered system to transfer
It's
the
a-
forces and make it durable.
It's complicated, you know. I mean, just this. You look at the connector like on our cable. It looks simple, but it took a lot of trial and error. We had to have the mold redone a few times to
Yeah.
fit the wire right. We had to find a very specific tubing to use for the strain relief that fit in the mold, where the plastic doesn't leak out the mold and you have blow through. You know,
it's
there was all
complicated
kinds of
potentially.
things. It's very difficult, you know. And you got to buy the injection molding machine. You got to have the mold made 2-3 times to get it
Yeah.
right.
It took all. It just
You know.
seemed like we were doing that for like months.
We
and
gave them the
months.
spec, and it's like it didn't matter because they don't make cables, right? They're
Right.
like, well, you might have some, you know, blow by or whatever the
Right.
plastic. Sure as hell we did. It's
Yeah.
like, so yeah, it's funny, but you know, it's but once it's done, it's
Oh, yeah.
so repeatable, it's beautiful. You know,
Now it's
It
great.
solves the problem without having to spend 20 minutes putting epoxy on the thing and super gluing everything together.
yeah,
And with these manual processes, you get very high cost and uncertainty. That's the key point. You could do something 100 times, 1, 2, 3 of them, you may have an issue. You may have something you didn't expect. There's some surface coating on the thing, oils that are residual that causes
All kinds of
this
reasons.
not to bond. There's a ton of reasons that cause potential for failures. Whereas with a plastic injection mold, something like that, if you design it right, that's not an issue. You get certainty.
of course, if you make cables aftermarket for headphones, you can't afford to buy an injection mold for every
No,
headphone
it's totally
out there.
unreasonable.
It's not
Yeah.
practical, you know. It's
Yeah.
too expensive.
I mean, you could.
Well, you could, but that, yeah, it'd be tough to get your money back on that if you're spending $5,000 for each mold,
Right.
just the mold.
Yeah.
To make one connector for one headphone.
Yeah, right.
It's-
Yeah, heat up the machine, put it in there. Yeah, so you know, it only makes sense if you're doing it in anything in volume.
Right.
You know, but in volume it does make a lot of sense because it just solves the problem of durability and reliability. So I think we're bored the hell out of everybody at this point about connectors on cables.
There's 3 people left.
Yeah, yeah. We'll probably hear from them in the comments and let us know if you're still here.
Yeah.
Well, I mean, and this is even a very simple 2-wire, cable. Imagine like
It's as simple as it gets.
HDMI, like you got 40 pins.
I can't imagine.
I mean,
Yeah.
you want an injection mold those.
If you see someone cut open these different cables, they may look similar on the outside. On the inside, they can be
Yeah.
wildly different. the
Most of them look
construction
pretty bad
methods.
on the inside.
Most of them look really bad. It's amazing. It works.
It's like what horrific solder joints, but you think about what they got to do to put
It's
this thing
complicated.
together.
It really is.
Yeah,
and
it's
high-end
crazy.
cables, oftentimes, if they're actually good quality manufacturers on like HDMI, they put a lot of effort in to make sure that they're durable, reliable, that they meet spec,
It's some
and they're assembled.
serious practice and skill sets
difficult.
assembling
It
those
is.
things. That's why we don't supply that cable. Anyway, we should probably get going. Thanks everyone for watching. Thumbs us up, and by all means, subscribe. Hit subscribe wherever that button is, because then you'll know what's coming next. Thanks.
Yeah.